So we had example 5.A.3, and this is what the given reads. A bicyclist travels to the right as she brakes. In one situation, she brakes only with the rear wheel, which we designate as rear wheel B. And in other situations, she brakes only with the front wheel, which we designate as wheel A.
And then our find reads, comment on the possible differences between rear wheel and front wheel braking as viewed from a dynamic perspective.
Right, so first off, we just want to say that we're thinking about this bike just as one rigid body and not breaking it down into three separate rigid bodies. So you could break it down into, wheel A and thinking about the reaction forces at this pin, and the same thing with wheel B. But to simplify it, we're just thinking about it as one rigid body that's moving this way. So for braking at B, if you're applying a brake force here, there's a force right at this contact point that's moving this way. And since there's a force outside of the center of gravity, that will cause a clockwise moment for the whole body. However, due to this moment, there will be the reaction force at A will increase to counteract this moment. So essentially you're applying a force here, this causes a moment this way, but this force can counteract that moment by increasing, which is why you feel a sensation of shifting forward, and then there's more force on your front wheel. And then, do you want to explain braking at A?
Yep. So then braking at point A over here, or on wheel A at contact point A, you're still going to have that force going in the negative X direction. That force is going to cause a clockwise moment about G. However, with there not being another reaction force up in front of A here, you are going to experience rotation of the entire system until you land on your face over your handlebars. So, yeah.
So that's what our thoughts are on this problem.